Living down here on Earth, it's easy to forget that we have it pretty good, at least in terms of our environment not doing everything it can to destroy us and everything we love. But that's not the case in space, and scientists have had to solve all sorts of challenges to keep space stations, probes, and satellites functioning in such an extreme environment. For example, they have to engineer their way around problems like temperature. Space can be extremely cold. The background temperature of space is minus 270 degrees Celsius in the shade. That's just a few degrees above absolute zero. But in direct sunlight, radiation can warm a spacecraft hundreds of degrees, especially as it gets closer to the sun. Temperature extremes like this cause equipment to contract and expand, which can damage or shatter it. And depending on the mission, engineers will have to either insulate their spacecraft from the cold or protect it from the heat. And sometimes they have to do both. The European Space Agency's Rosetta mission, for example, had to chase down a comet. To get there, Rosetta had to do several planetary flybys before heading out toward the asteroid belt on a 10-year journey. During that time, it went through wild temperature fluctuations. So to overcome this, engineers fitted Rosetta with metal slats, or louvres, that could open to let heat radiate away, or close to trap it and keep the probe warm and cozy. Comets like the one Rosetta caught leave a trail of dust in their wake. These are frequently the cause of meteor showers that we're seeing here on Earth. The little dust particles can also pose a threat to spacecraft because they're traveling at thousands of kilometers per hour. They can have the effect of sandblasting solar arrays, harming lenses and optics, or damaging the structure of the spacecraft outright. The best strategy is avoidance. Chart a course where you don't think there's going to be a lot of debris. But if it's unavoidable, there are measures that you can take. For example, the Hubble telescope passes through a meteor shower occasionally, and scientists will have to rotate it so the big solar panels are edge-on to the incoming hazard, minimizing its surface area, like a fencer standing sideways. But even if a spacecraft can keep itself at the right temperature and avoid physical impacts, there's another hazard that will always get them in the end. Spacecraft are exposed to extreme radiation all the time, mostly in the form of high-energy charged particles. The particles can come from the sun or just be zipping around the galaxy as cosmic rays. They can also be trapped by the Earth's magnetic field, forming enormous bands of protons and electrons called the Van Allen belts. Not only do these particles pose a threat to humans, but they can damage the electronics inside of spacecraft as well. They can cause a current to flow on the surface of a craft, for example, or burn out computer chips. They can even change the contents of individual memory cells, corrupting the data the spacecraft's computers need to function. If the computers fail or valuable data gets corrupted, a whole mission can be ruined. So engineers have to come up with strategies to protect this electronic equipment from radiation in space. It's known as space hardening. They can try and shield the electronics, but the shielding is heavy and weight adds cost to the launch. So spacecraft have redundant electronics, like 3 chips performing the same operation simultaneously. If radiation causes one to make an error, the other 2 can check its work and overrule it. This way they can just use commercial electronics too, which is cheaper. Interestingly, electronics today are more sensitive to space radiation than they were in the 60s and 70s. To make them more robust, the chips themselves can be designed in such a way that makes them resistant to radiation. Designing hardened chips is difficult and expensive though. So one of the most popular chips still in use has the processing power of a laptop from almost 2 decades ago. Even with all these precautions, the best spaceborne electronics are still eventually going to fail. For more epic stories of innovation that shaped our future, check out theageofaerospace.com. If you like this video, don't forget to take a second and subscribe. Despite the challenges, we have launched an absurd number of satellites into space. Is there room for more? Amy covers that here. One cool thing about Rosetta's louvres is that they open and close automatically. The springs are temperature sensitive because of the metals they were made of, so they use no power.